Welcome to qnawire.
In this problem, we've got two plane mirrors, M1 and M2, and M2 is placed at an angle of 120 degrees from M1, shown right here. And we've got a light ray striking M1 at an angle of incidence of 65 degrees. And it's being reflected back and then striking M2, and then being reflected back again, and leaving at an angle of reflection of theta, which we have to find. And we're gonna do that using some simple angle properties. And we can start by saying that, well, the angle of reflection right here when the ray first strikes M1 is going to be equal to the angle of incidence. So the angle of reflection is also going to be 65. And then we can see that this triangle right here, we know one of the angles is 120. We can figure out this angle by noticing that this line right here forms a normal. So we can subtract 65 from 90, which gives us this angle as 25 degrees. And we know that this small triangle right here, the total sum of the angles, so 1, 2, and 3 angles, if you sum them up, it should be equal to 180. So if you subtract 120 plus 25 from 180, that would give us this angle right here, which should be equal to 35 degrees. Using that, we can again use the fact that this right here is a normal. So this total angle is 90 between the mirror and the normal. So if we subtract 35 from 90, we get this angle, which is 55. And we can see finally that this 55 is actually the angle of incidence of our ray. And because this is a plane mirror, it should be equal to the angle of reflection. So the angle at which the ray leaves M2, so that's theta, should be equal to 55.